Okay. Okay, this is the program to compute the area of circle, and it began with the importing libraries NumPy and Matplotlib. N equal 1000, which is the number of points to uniformly cover the region, the square region. In this region, we generate the random numbers, X random number and Y random number. So they are in the region. We compute whether the point is inside the circle or not, and we plot it with the different colors. So inside it is the red color, red circle, and outside it is being plotted with the blue circle. There is area computation. So good programming practice is to write in the function form, right? So yes. We counted the red points which are inside the desired region. Here in the area of the region, I computed the probability number of red points divided by the total number. So probability is proportional to the area, and then the area of whole circle, it should be 4 times of the area of region. So now make it in the form of a function. So I keep this n as variable. So I define a function, and it is, say, it is calculation pi, right? It contains one variable n. When it takes the n value, it performs all these calculations. So with the definition of function command, I have to give it an indent, and then after the computation of circular region, the value, you can say return this value, return the value of a circle as the output of this program, right? Okay. And then just to make it distinct, I generally use a dashed line, a comment dashed line. Now let's run this function and see whether there are errors or not. So this function has been written correctly. Now I can compute the values, not with the a circle. Now I have to write calculation I, which is the name of the function, and for n values, say 100. Let me check the name. CALC underscore pi and n. CALC. What was the error? Yes, cal pi was not defined, so calc C. So with 100 points, we have got the figure value. Where is the value? Okay, 3.08, right? So calc pi 1000. I will get two values, 2.92 for 100, and for 1000 it is 3.16. Now in order to compute several values, for one fixed value of n, so I can say n equal, say, 1000, right? And I will store the values, say 5 values. So I can say numpy zeros and 5 values of type float. So this will create a vector. And now I write for jj in range 5. I compute 5 values 5 times I compute the pi value, or the area calculation program will be executed 5 times with different random number seed. So let's see the variations. So I call calc pi for n. See here n is same, right? And 5 times calculation will be performed. And for writing purpose, let's write here a print command for a jj value, jj equal jj, and I say value equals well, you can use, it is just a variable. It's a variable. Actually, the j alphabet is reserved for complex numbers, j and I. Therefore, in programming, in MATLAB, Python, and all high-level programming languages, we avoid using I and j as a variable, right? So we use jj. You can use anything. So 5 values of the area will be computed with the same function. So see the variation: 3.128, 3.124, 3.1, 3.068, 3.076. We have repeated the experiment, right? So when you repeat the experiment, so you can have an estimate of its variation. So in order to study the variation, we define statistical parameters like mean value and standard deviation. So I can say mean of value. So it is from numpy, mean of value, variable. For standard deviation, I can say standard deviation of val. It is numpy std val. And for variance of values in the vector, I can say numpy variance of value. Let's see the size of variation spread. These are essential computational elements when you do Monte Carlo simulation. So you have to report a mean value. Oh, I didn't write any command to see them. Well, they have been computed correctly. It means I have written the syntax correctly. So I say, okay, mean value, standard deviation value, and variance value. Okay, so mean value is 3.0992. Standard deviation is 0.02. So that is the measure of spread. And variance value, okay, if it is required, you can use it.